All right, 3.5, day 1, part 3. A radioactive isotope has a half-life of 11.9 hours. There's 130 grams. How long will it take for it to decay to 10 grams? So we have that initial equation, a sub t, a sub naught, 0.5 raised to the t over k. A radioactive isotope has a half-life of 11.9 hours. So where is that going to go? It's telling us how long it takes for the isotope to decrease by half. So 11.9 hours is what in this equation? It's the K. So it doesn't always have to be years. And then it says, if there is 130 grams, how long will it take for it to decay to 10 grams? So where is the 130 grams going to go? It's going to be the initial amount, yep. And then over time, it's going to decrease in value, it's decaying. So that would, 10 grams would be your A sub t. And what's your unknown? What are you solving for? The time. The time is your question mark. All right, so let's go ahead and substitute those pieces into the equation. So we said our A sub t is 10 grams. Our initial is 130 grams. 0.5 is its half-life. T is our unknown, and then 11.9 hours. And we have to solve this equation for t. So think back to how you solve exponential equations. What should we do first? Divide by 130, yep. So 10 divided by 130 equals 0.5 raised to the t over 11.9. So 10 divided by 130. What might I want to do next? How do you bring the exponent down in front? Yep, natural log both sides so you can bring that exponent down in front. So now that exponent will pop in front. Now it's t over 11.9 times the natural log of 0.5. And then the left side still is the same. Okay, what do we want to do next? Very good. Get rid of that natural log of 0.5 on the right. So divide it. All right, so let's enter that into our calculator. The natural log of 0.07692 divided by the natural log of 0.5 to approximately 3.7. Last step. Then multiply both sides by 11.9. because right now the T is dividing 11.9, so multiply it. So T is approximately 44.03, and what's our units? Hours. All right, last question on half-life. I would recommend that you write this one down too. The half-life of a radioactive radium, that same 226 radium, is the 1620 years. And we want to figure out what is the percentage amount of radioactive radium that will remain after 100 years. So it takes 1620 years for it to decrease by half. So we haven't gone very far. We've gone 100 years out of 1620 years for it to decrease by half. So will my percentage be high or low? How much will I have still in radium? A lot left. So I use that same formula, or the, if you like this one, y equals CE to the KT, that also works. So I've entered pieces into the formula for you. It's not asking you what you started with, what's your initial, so that can just be 1. So for this one, yeah, you're going to see these formulas a lot, yep. So it's saying E raised to the -1/2 times 100 over 1620, because we've gone 100 years out of the 1620 years, they can decrease it by half. And when you enter that into your calculator is going to look like this. Just initial amount can be any value. Yep. So you don't really need it. The calculator is going to look like this. 0.9696. That's in decimal form. But they're asking for the percentage. So then we have to just convert it 2 places to the right. So be careful there. So we have still left in radium about 97% of our initial quantity after 100 years, is what this problem is telling you. That's another style problem. And you're able to enter that in your calculator, okay, and get the answer? So you may want to do your fraction and multiply by -1/2, and then raise that decimal to the E. I'm going to stop there.